Thank you very much. So good afternoon. First, I would like to apologize to Sylvian Grellet because he couldn't attend this session today, and I will present his presentation today instead of him. How do you use this, please? Thank you. So the presentation will have information about the OGC Hydrology Domain Working Group, information and results from the surface water interoperability experiment, some information about the development and status and ideas from French water information system, and ideas for supporting the interface with European directives. For the beginning, let's look at a very common situation that probably you know quite well. Let's imagine one nice guy, Jack, who desperately needs specific data and finds a solution to call Don. So based on this call, Don has time and is very kind as well, and he decided to find the data, and after a few minutes, data ready and sent back to Jack. After a few time, Jack got ideas for some more questions. Where is the site located? And Don replies, okay, it's at Laughing Jack Bridge. And coordinates. He finds the coordinates and sends back and tell them to Jack. What about the reference system? Okay, I think it's GDA 94. Okay, what sensor is used? It's calculated from the string gauge reading using a rating curve. Ooh, how accurate is that? And the result of this conversation is end of conversation and exchange of information flow. So let's move away from this situation and to see how we can change and improve the exchange of data. The OGC Hydrology Domain Working Group is a joint working group established with Water Meteorological Organization and the OGC with the purpose to improve the venues and mechanisms how to exchange hydrological and hydrographic data. The members of the group are quite wide, coming from different organizations, from different companies as well, from different countries and from different continents. The main activities of the domain working group is focused on the analysis and harmonization of existing protocols and standards in the domain, to set up certain projects which are testing the possibility for interoperability in a specific water domains, but also to set up pilot projects which are focused more on entire domains and across domains. One of the results of this group are submitted as discussion papers and best practice papers to other technical committees in the OGC. And they are keeping a very wide communication with other domain working groups, with which they can exchange data on data modeling, handling grid data, and real-time data management. So these common areas are basis for quite wide cooperation between different domain working groups. Currently, the OGC Hydrology Domain Working Group has a few ongoing projects. The most important one is related to the water ML, which supports encoding of hydrological and hydrogeological observation data in a variety of exchange scenarios, where they plan also not to focus only on this project, but in the future to plan further projects extending the water ML, going more into water quality and not that much into water quantity, as it was the case in the part one. Other potential future projects are more related to hydrological features and vocabularies, and keeping the joint communication with Met-Ocean on flood forecasting and extending the work on the groundwater ML. Hydrology Domain Working Group is dealing with observations coming from different facilities and related to very diverse issues of water-related data, measuring the water quantity, the water in the soil, the groundwater quantity and quality of the waters, and dealing with water in meteorology as well. The Water ML is one of the projects that this group was actually developing, proposes the data model to exchange the water monitoring observations, which, as I said, currently was more focused on the water quantity. And in part one of this project, the main focus on how to present and encode the time series, is many of the data provided from measurements and exchange are actually depending on or providing the certain time series. The basis for the Water ML is actually ISO standard, observations and measurements, and schema for coverage and geometry and functions, which is further specialized exactly for the purpose of Water ML, supporting the water observations and water quantity. A specific project was set up, Surface Water Interoperability Experiment, with several goals. Objective of this project was to test the Water ML within practical use cases, and also to test the use of the OGC architecture and services, how the water quantity monitoring observations data can actually be exchanged across the cross-border situation. The use case that was used for this cross-border situation was the use case on Rhine River, but other use cases that were tested tested for the Water ML were presenting global runoff, where the case of the Mississippi River was taken, and the flood forecast, where the test was more oriented into the performance testing, the questions related to the exchange of huge amount of data, the time pressure, exchange and processing of data in a very short time, and dealing with simulated values. If we continue with the results of the surface water interoperability experiment, the standardized information flows were actually tested coming from two different information systems, one in France and one in Germany. The purpose was to check how the ability to exchange on cross-border situation actually works. Collecting the data from different stations from France and from Germany, and to exchange the data like their observed parameters, processes, observations, and measurements. Inside this project, an important step was achieved to develop the common generic interface which were used to present the data from both systems, and to present different ways how to manipulate the information exchange. And another important outcome of this project was also some important feedback from these practical experiences that were provided back to the development of Water ML standards in the OGC. Going into the existing information system in France, which has a quite long tradition and experiences running for 20 years, the system is based on the shared architecture, but also on shared data models and services, and supports the development of common vocabularies wherever this is possible. Many partners in France are participating in this project, from governments, public authorities at different levels, to other institutions and organizations. The common standardization concepts are developed through SANDER, National Service for Water Data and Common Repositories Management. The basic idea is to have the service-oriented architecture, to collect the data once and use them many times, to provide an entry point into the most important referential data sets, but to keep the data outside of the centralized approach, to keep them on the level of the producer. The development of this water information system went through different stages. To enhance the interoperability with other initiatives like WISE and INSPIRE, they decided to change also, to transfer the existing data models from entity relationships type of data models into UML, which was the basis later to find a proper way how to convert those data models into the ISO compliant data models. At the same time, they are planning to translate some of the data models into English for further to emphasize further exchange of data with other partners. Well, some of the reasons why the implementation of the standards is so important is that with the implementation of standards, the new technical solutions will be easier to deploy, the exchange of data will be easier to manage. This might reduce the burden of the implementation phase. And for all of this, and the use of standards, for instance, like OGC standards OGC services, is always evaluated within the French water information systems to access the added value for such an implementation within the system. One of such examples was also the using of the results of the service water interoperability experiment. Other ongoing activities, ongoing projects related to water information system are feature versioning, dereferencing external controlled vocabulary for XML validation, testing the push-pull mechanisms to update the national referential data sets. And at the end, one of the important questions, why it is so important to be involved in the hydro domain working group. For them, most of all, is to share the experiences and common issues with other water information systems and to support the progress together toward common situations. Another important point is also how to underpin the environmental policies and what kind of roles different organizations can have in this process. The International Office for Water is already acting and cooperating with many different organizations and members, and they are seeing their role as a mediator for the European water community, bringing together on one side the requirements from different European directives and other international obligations to include the member states' needs and to follow the standardization processes to provide a solid basis for the communities that could move in a common direction and not in the opposite directions. Keeping this role, they are seeing that mediators should be neutral at the core of data management, aware of the main constraints of the respective actors. Some other activities which are currently ongoing in this underpinning, within the process of underpinning environmental policies is involvement of many different core groups dealing with water-related issues. So one of these is Water Information System for Europe technical group, which help technical decisions which supports the technical decisions based on national experiences, where the French water information system can participate with their experiences. Another cooperation is related to the INSPIRE data specifications development, with high participation in environmental monitoring facilities, special data team, and in observation and measurements guidelines, and in cooperation in other data specifications, which are using both of those topics. During this inspired data specification and development process, there was many activities and cooperative work with other thematic working groups. One of them is also area management and reporting units. So, a few conclusions. Why open standards? Open standards should help data models being interoperable and providing the common data structures that can be easier shared. The open standards should also facilitate data exchange via shared web services and therefore presenting the common transfer vehicles for future development of different web services for different users. And most of all, to ease environmental policy implementation and also to reduce a little bit the burden of member states to provide data for different reporting obligations and other legislative obligations. Thank you very much. I would close here.